again, welcome everybody to our webinar, which is going to be focused on Myovision's next generation hardware, the core, and unlocking traffic insights using the recently acquired Traffop cloud-based software platform. Again, we really appreciate you taking time out of your busy day to attend with us today. And I'm very happy to have Brent Rogerson and Zach Ogden here from Myovision to join us. Before we get started, I just want to make sure everyone's aware, on the right-hand side of your screen, you do have a panel where you can ask questions. So anything that comes to mind during the presentation, please feel free to record them in that panel. And then at the end of the presentation, we will address all questions. And it would be great to have a nice list waiting for us at the end, and we'll jump into that section. As a reminder as well, at the end of the presentation, we're going to be having a little quiz, which will include a giveaway of a bundle of Stinson ITS goodies. So it pays to pay attention. So let's take a quick peek at today's agenda. So first off, we're going to be introducing Myovision's next generation hardware, the core. As many of you may know, historically, Myovision TrafficLink systems came with two components, the SmartLink device and the SmartSense device, one for computing and one for aggregating data from the cabinet. So Myovision has blended these two components together into one compact, simple device, which will reduce the cabinet footprint of the Myovision hardware, allow for easier installations, and of course more integration as more features and software features are released with the Myovision TrafficLink platform. So this product will still provide the continuous multimodal counts, detection, video monitoring, the ATSPM feed, as well as the ability to pull data from multiple cabinet sources like your controller, like your conflict monitor, and send out alerts based on what those devices are doing. And then we will get into something new from Myovision, Traffop. So just a bit of history on Traffop. In 2021, Myovision acquired fellow software company, a traffic software company known as Traffop. And Traffop is a software-only solution which overlays on any advanced traffic controller, providing a wide array of data and reporting and single performance metrics. The really nice thing about Traffop is that it doesn't matter which controller brand you're using. It's not tied to a specific controller or a specific piece of hardware in the cabinet. It's agnostic. So as long as your controller is producing a high resolution data feed or an ATC controller, then you're compatible with the system, with Traffop, and you can overlay it as a software-based addition to your ATMS. So what we're going to go over with the Traffop platform specifically, Brent will review the value proposition behind Traffop, including why a municipality would want to explore a Traffop deployment, the benefits derived from Traffop, and how different agency stakeholders would benefit from having Traffop in their, in their roster, how problems are identified and solved using the platform, and how data-driven solutions, data-driven networks tend to lead to more efficient decision-making within your agency. And finally, we will conclude today's presentation with a live demonstration of Traffop, which I'm personally excited to see. So I'd like to take this time now to introduce Brent and Zach. So Brent, if you want to go ahead.
Hey, thanks Harrison. And hey everyone, thanks for having us today. We're really excited to talk through the product and talk through some of the value that our detection system brings, as well as the overall Traffop platform that I'll show later on today. And so, as Harrison said, my name is Brent Rogerson. I'm a sales engineer here at Myovision, and I'm really excited to take you through this today. And we're joined here as well by Zach. Maybe Zach can introduce himself as well.
Yeah, hi everyone, and thanks again for taking the time to meet with us today, and thank you to Stinson for organizing this webinar. Excited to talk about the new hardware and software options. So,
thanks guys. Thanks for coming. I'll introduce myself quickly. I'm Harrison McDonald. I'm an account manager here at Stinson ITS. I recently joined the company, but I've spent my whole career in the traffic industry, which has been about 7 years since graduating university. and I'm really excited to be with the Stinson team. Very quickly, I'm going to go over a bit of what we do here at Stinson ITS. We are a Canadian manufacturer, a distributor, and a systems integrator for intelligent transportation systems. We offer a wide variety of great products, ranging from sensors, safety devices, a lot of different consultative sales that we do where we bring multiple products together and integrate them into a custom solution. And currently we're working on some very cool projects across Canada. Our head office is located in Woodbridge, Ontario, but we do have account managers across the country. So now Zach will take over here to discuss a bit about Myovision and the core. Thank you, Zach.
Yeah, thanks, Harrison. Again, I'm the territory sales lead for Myovision Canada, so I work closely with all the Stinson sellers and the Stinson team across the country, and we're fortunate to have such a strong partner in market, and excited to talk a little bit about some of the hardware and software solutions that we're bringing to market this year. So to begin, I want to talk a bit about why Myovision and really how we're thinking differently about smart intersections. So as the size and dynamics of cities are rapidly changing, our team is really focused on how we can help solve problems for your citizens faster, more efficient, and more effective than was previously possible. So how have we done this? The industry's traditionally utilized a proprietary technology approach to influence cities into vendor lock-in. So in contrast, and more recently, even so over the last couple of years, we've taken more of an open technology approach to ensure ease of integration into other parts of your organization and existing solutions. So we think about this sort of as the smartphone model, where there's a piece or pieces of hardware, in this case the core DCM, which we're going to talk about, which enables us to then provide solutions that are not only currently available today, but also ones that will become available down the road, essentially future-proofing your investment in your infrastructure. So you can see on this slide we have excellent implementation throughout Eastern Canada and the United States, or Eastern United States, but being a Canadian company based here in Kitchener-Waterloo and working with Stinson, we're really looking forward to continue to implement our solutions and grow our presence in our own backyard. So before we get into new hardware, I also want to talk a little bit about how Myovision and Stinson are approaching the relationship building with cities. So with advancements in intersection technology, we like to think of cities as sort of existing on a hierarchy of adoption of such technologies. So in this slide, the darker blue would be sort of the hardware solutions, and the lighter blue, the software solutions. So we really want to meet customers where they're at on this hierarchy. And the new solutions we're talking about today allow us to do just that. So, at the basic level, we're talking about basic operational awareness and answering questions like, what's going on at the intersection? Is there power at my signals? Are the existing sensors working properly, etc.? And the core device really looks at the first sort of two levels of this hierarchy, right? The traffic management and operations, and then things such as video detection counts and integration with other data sources. Whereas the Traffop portion focuses more so on that third level of the hierarchy and above. And so at another time, I'd be happy to discuss how we've sort of taken this approach of meeting customers in cities where they're at and working with them. But ultimately, it starts with a discussion on where you're currently at and what problems you're trying to solve today and what problems you're looking to solve in the future. So at the heart of our ability to meet cities where they're at and begin offering solutions to their problems with immediate benefits and a roadmap into the future really starts with our new hardware, the core and the core DCM. So on this side, what you'll see is the core unit and the four main components for the entire solution. So the first picture at the top is the Myovision core unit itself, which provides cellular comms and a GPU to turn video into traffic data. The second picture you'll notice looks a lot like the top, but that is actually the DCM, which stands for Detection and Counts Module. And if you'll notice, the bottom right corner is blue, so it's a plug and play piece of hardware with another GPU that provides roadside video analysis for detection and counts. Excuse me. The next component is similar to our Gen 1 equipment. It comes with the TrafficLink antenna, which sits on the exterior of the cabinet for communications over cell and connection to the cloud. And then the final piece of the solution is the 360 camera, which captures video as input for analysis. So we're not going to go through this entire video. I don't think the volume's going to play, so I talk through it a little bit. So that is the Myovision core. As you'll see, it has the black box in the bottom left corner. As it is, that's a fan control module. And the one on the right, if you want to enable detection and counts, it's a plug and play detection and counts module. So this can be slid right out while it's in operation, while it's live in the cabinet, as you can see. And I guess we won't play too much more of the video. It's compatible with actuation over SDLC and GPIO as well. So that's the quick overview of the hardware. My colleague Brent Rogerson is going to now go into a bit of the use cases and capabilities of the core and core DCM before pivoting into a focus on the software solution Traffop.
Awesome, thanks, Zach. So I'll just go over here. So as you can see, the hardware is designed to fit into a standard traffic cabinet. We connect over SDLC, which essentially implies that it's detection for actuation as well as the benefit of counts. So the hardware itself focuses quite a bit on these two applications, but it also enables features like communications and enhances the collection of data from the traffic controller as well as from the video detection itself, and you'll kind of see how that comes together. So the first major application of the device, and you can kind of see it all three of them together here on the right, plus a little bit of a clip of it in action right on the top right. So the main purpose that our customers do buy this for today is the video detection for actuation. Myovision has lots of experience in both video data collection from our previous product, the Scout, as well as from all of our permanent installations, as you saw on the map earlier, to enable us to do video detection for actuation at the intersection. And you'll see as the objects come into the frame, they're all being identified individually, and then calls and detection are being placed via the green indication that's happening on the zone. Our system both detects and classifies vehicles, pedestrians, and the cyclists within the frame, and that it also breaks down those classifications even further to allow for a rich data set. Similar to how any other detection system works, it allows us to safely operate the intersection, put things into recall when they're not operating, manage it safely for when conditions are optimal and all the hardware is working and everything is going the way that you intend. Everything works in a very high caliber environment. We have passed a lot and most of, if not all, the product approval labs across the US, and we're slowly integrating everything into the Canadian market with approaching about 1,000 intersections in the Canadian market now, with a very high-powered GPU engine at the side of the road doing detection for actuation, as well as a lot of the performance measures that we'll get into as well in a second. So the second application there that is the big driver of this device is the counts application. And if you're familiar with our Scout product, Myovision built our company around its ability to provide accurate counts from video. We're able to do it 24/7, 365 as a permanent count station, as well as a detection for actuation system. And you can see it detecting and classifying at the same time. This allows us to get a continuous count, and you can see a little bit of a chart on the bottom left that you can see the profiles throughout the day, as well as all the classification and little turning movement count diagram there on the left that you may be familiar with from the Scout product. We leverage the same platforms between both of our products, and we are very excited about the auditability of the video in the same way that we've always been building our products. You have to be able to verify the data, and you have to be able to rely on it throughout all conditions. So for that reason, we have launched this core DCM device that is incredibly high powered for the Canadian market, and it delivers quite a rich data set along the way. Just building on that a little bit further, this is a pretty good view of all the different capabilities that you can see all at the same time. Often from a single point camera, so it is a 360 camera that we often deploy. You can see the range of it for the most part in the video itself, and we can see almost up to 200 feet from a single point camera, where you need essentially a second camera. You can just simply add it and then just build the data set between two cameras and do detection between the two as well. But you can see almost the view on the right, where we can break virtually the view up into multiple views in a way that you can almost simultaneously view 9 different approaches or 9 different views at the same time, do things specifically for pedestrians, specifically for bikes, and as well for all the vehicle actuation and counts, all simultaneously from a single device at the side of the road. This keeps the real estate needs very low at the cabinet side, and also delivers the caliber that you need for the data collection they need as well. One of the most exciting things that we have seen our customers use this platform for, and the detection application, is not just its ability to actuate accurately, but also the extreme scenarios of events and the extreme scenarios of counts that have traditionally been almost impossible to collect from a manual standpoint, or even traditional collection tools. So from a video standpoint, being able to handle extreme pedestrian volumes in a high accuracy, when I mean high accuracy, well above 90%, in large quantities, in a way that you can really understand behaviors of the intersection, and you can really understand how signals should be timed, as well as how to manage scenarios like this at an event stage, where you just want to understand how are the pedestrians interacting with the intersection, not necessarily just how many, but starts mapping it out and actually providing the actuation that it's capable of. Oh, so we have a poll question where I guess we're curious to see, maybe Harrison, I'm not sure if you're going to launch the question piece here.
Hey, Brett. Yes, I'm just trying to launch that right now. Oh, there we go. Perfect. Okay, so the poll. What type of detection do you use? You can select all that apply. So if you're using multiple forms of detection, feel free to click multiple boxes, and then we'll go over the results shortly. Just give us a few minutes here.
Oh, nice. Good to see all the responses coming in.
Yep, looks like we got about 59% of the population voting, 61 now. So we'll wait till it gets around 70, and then we'll. Okay, so we had about 63% of you voting, and it looks like loops topped the chart with 78% of municipalities using loops, 53% using some form of radar, whether that be side fire or forward fire, 66% on video, and 9% not currently using any detection. This is pretty, pretty common from what we would expect. Each of these methods of detection all have their merits. The loop is the tried and true, robust, very accurate detector, commonly deployed for nearly all cities in some way, shape, or form. Again, radar is a good weather-resistant technology. So it really depends. what you're looking for as an agency. With video, there is the added benefit of being able to gather, a deep set of statistics, including that pedestrian data, advanced classification, and of course having the benefit of being able to remotely view your intersection from wherever you are, as long as you have that internet connection to the intersection. So thank you for participating in that poll, and let's jump right back into the presentation.
Awesome. All right. So that was great. Thanks for doing that, and we'll transition a little bit over to the performance measure data side now. One of the things that Zach touched on a little bit is meeting everybody where they're at and building on the data sets and building on the platform that can actually derive at signal performance measures and optimization of the intersection. And to some degree, based on some of those responses that we just saw too, it's going to be a combination of sensors and data sources from building out your network in terms of understanding the performance measures. So as even Harrison indicated, recently Myovision acquired a tool called Traffop. Traffop is 100% geared towards signal performance measures and optimization, and we are adopting this into the Myovision suite of tools and into our platform. So you'll likely see things evolving like this if you're a customer of ours today. And so what that means is we're starting to really focus on how to make performance measures more powerful given all of the technologies out in the field. So Traffop is really trying to solve the problem of evolving from basic data sets or evolving from conjecture and actually start applying into a real improvement of the optimization given all the data and start making data-driven decisions, not necessarily just anecdotal evidence or just basic things that are occurring out there based on observation. Let's get right into the heart of data and build on top of it. But it does get more complex. We all have various stakeholders. We have different objectives, and we all have different focuses between all of our teams. So very high level approach to how Traffop is going to try and solve this, and I'll show you this in a minute, is actually trying to address the needs of everybody in the transportation agency. So talking about how do we help the signal techs actually resolve problems? How do we help minimize functional issues and limit citizen complaints? How do we really optimize the intersections and improve safety with the signal planners? And then as everybody has managers, always looking for that return on investment. How does an agency invest in something and get the expected outcomes and gains that they're really going after? And then for all of us, our customers, the public, really ensuring that we're creating that positive transportation experience that considers safe transportation as well as optimized ways and routes and things like that. Often this ends up being a political type of conversation, so building dashboards and tools to really help talk about these improvements that are being made in a way that the public can understand it, in the way that political platforms can really help drive those initiatives are a really important piece to us and how this platform has actually addressed it. When we went to market with this product, the first thing that we asked is quite a bit around the skill set and use of performance measures today. And so through a survey, we learned that 78% of the respondents to this survey expressed that typical ATSPMs, although useful, are actually really difficult to use or they require too much time. So similar to any other product, the quality and functionality can be extremely different one vendor to another. And so what we really tried to hone in on here was how do we make it vendor agnostic? How do we make the data very easy, the UI very simple to use, and really make sure that we can tackle this anxiety piece of how to leverage data and to focus on the data and not really the complexity of collecting it and use a platform to do a lot of that legwork for us and maybe convert some of these 78% of these people into power users of data and creating those outcomes. So just quickly before I do a quick demo of the platform, I certainly won't be able to go too deep in our webinar today, but I'll try and do a high level pass. Just breaking down some of those problems that the platform is trying to address. One of the number ones that comes up in our conversations is reducing citizens' complaints. The citizens are our customer in many ways, proactively monitoring the network, trying to ensure that things are operating physically the way we expect them to, respond better to issues, and then ultimately save time and money for that agency to ensure these problems are being addressed, keep crews out of the field if they don't need to be there. The problem is not a priority. Learn to prioritize those problems in better ways, and really understand where this most severe issue is occurring and work your way backwards from there. So really understand what's happening in the network so that most of these things hopefully don't turn into citizen complaints before you can resolve them. Next, a more obvious one when it comes to performance measures is the congestion mitigation programs. Every one of us are all trying to help with these aspects and building tools to specifically focus on improving delay, reducing emissions, and then ultimately reducing fuel consumption. We want to make sure that we're not necessarily just optimizing the intersection for the sake of time, but really also considering the environmental factors that can be a great outcome of improving all of these intersection optimization issues. And then finding ways to measure that ultimately is what the platform is trying to address. Improving safety, this has got to be number one on most people's lists, on the highest item that everyone should be considering. So how can it address maintenance and infrastructure to improve public safety, like how are individuals interacting with the signal, is it operating the way it should be, are people getting adequate amount of time, is the hardware and the infrastructure working the way it should. Reduce those workplace hazards by keeping staff off the road if they're not necessarily needing to be there. If the issues can be addressed remotely, certainly give them the tools that they can do to stay off the streets. And then ultimately make those corridors safer by proper optimizations and proper signal timing to reduce crashes and ultimately property damage and things like that as well. Safety is always number one, and we want to make sure we're providing the right amount of data for those things to be resolved. And then looking to some of those end users and those stakeholders, building out measurable, reportable impacts of all that effort that you're doing in the platform. So before, after studies, trend dashboards, and executive reports, so that all of the work on signal timing to maintenance and operations can be represented in a way that each one of those individual users can present what they have done to make an improvement. And then those can be building blocks to continuously build that network in ways that you can constantly iterate on your network and go forward instead of just trying to react to the citizen complaints that are happening, build on the dashboards, deploy resources where you need them to be, and then ultimately report on those executive reports like cost savings, fuel savings, and emission savings. ATSPMs bring the benefits from the traffic network of continuously available data, continuous automated insights and alerts so that you can react to them before citizens are reporting them, data that is comparable across the entire system so you can really leverage how is it working here today versus how did it do over the last few months, and then turn all of that continuous data into shareable reports to ensure that the entire network is incredibly visible. Then just to tie it home back to something that Zach mentioned quite earlier on in the discussion that we had here, is meeting the agency where you're at. So going back to that hierarchy again, I think it's an incredibly powerful tool to understand that you can't necessarily just jump to the end of the conversation or end of the perfect state scenario. You got to build towards it, create those building blocks of the right equipment out in the field, the high-res data, the right detection systems, build on the maintenance operations, improve local control through detection, and then ultimately start deploying things like system control and adaptive tools and understanding what the right tool sets are throughout the entire network so that you have a full visibility that you need, and create those building blocks so that you can continuously move forward to what your ITS or even your transportation goals really are. So we do have a quiz question right before we get into the demo, I guess.
Yes, let's get that quiz question up on the board. So I believe, Samantha, if I'm not mistaken, it's the first person to answer this question correctly will receive our package of Stinson prizes.
Correct. So just put your answers in the questions tab on the right side.
You see that tab? It's the second from the bottom on the right side of your GoToWebinar screen, and the first person to answer correctly will receive a package of Stinson goodies. So yeah, let's run that question. So what percentage of respondents to a survey expressed that typically ATSPMs, although useful, are either too difficult to use or require too much time? Now that was given earlier in the presentation, so first person to answer correctly will receive a prize. Okay,
If you
let's
click
see. Let's go through
one more time,
SmartLink.
there are multiple choice.
Yeah, just click that presentation one more time, Brent.
It's not a big deal. People have a good memory, apparently. They've already answered the correct answer without seeing the options. It's very impressive. Tyler, it looks like you were the first person to answer correctly, so I will contact you afterwards via email to get your shipping address.
Congratulations, Tyler.
Awesome.
Excellent memory.
Awesome. All right. Well, that was fun. That was fun. Seeing how the respondents come in, and it was a lot faster than I expected.
Yeah.
All right. Well, with that said, we have about 10 minutes left here, so I'm going to do a quick demonstration, and then we'll open it up to the group for any questions, and we'll be happy to stick around and answer any of them. But yeah, let me just get out of this quickly, and then we'll go do a quick demonstration. I guess right before I do that demonstration, maybe just to clarify what the data source is that we're looking at in the platform here, and it's just 1 second, but maybe it's a helpful piece. So the way this platform actually collects data is through the high-res data loggers of the traffic controller. So it's very vendor agnostic in the sense of it doesn't matter what detection sources you have, what how many signals or how many different approaches. It doesn't necessarily matter what the source of the sensor is. Every piece of the data in this platform is coming from the high-res data sets from the traffic controllers. So it is a little bit of a prerequisite to have an ATC controller, but most controllers today have this ability and have this functionality built in. It's just a matter of turning it on and leveraging it. And so we take in this high-res data through a virtual machine on a network and just outbound that data to the platform, and then you can leverage the data all you want into the platform, and I'll show you what that looks like today. This is how we turn it into insights and dashboards and SPMs, comes from those high-res data. So let me go over to the platform now. So just quick tour of the platform. This is the Miovision Traffop toolset. As you can see, when I first go into it, there's a nice map overview of your entire network. You can see where you have corridors, where you have standalone intersections, which can almost apply some of the timing plans that you may be leveraging at those intersections as well. Along the left here, I'll kind of work my way down the list a little bit just to show you what's in here and what's possible. We'll go through some of the insights. We're on the map overview right now. We'll go through some of the signal performance measures without really getting into the data, but just showing you what's available. We'll get into those dashboards and then ultimately some of the corridor dashboards as well. So quickly on the insights, similar to what we were talking about, equipment insights, maintenance insights, operational insights, and performance insights can all be highlighted on the map. So when I click on the map, you can see right away a lot of the variations of performance are automatically highlighted in a way that we can start drilling into each one of these issues. And you can see on the right how the system state overview is somewhat grading the severity. The severity of a detector that's stuck in recall is different than a signal or a controller degrading, if you will. And so grading the severity is an important piece. And obviously red is more severe than green, and actually addressing them accordingly. And so when you look at each one of these things, you can highlight over top of them. We can click on a particular intersection. It'll highlight what is going on there. Is it a maintenance insight? So here it's saying that detectors are stuck. There's also intermittent stuck detectors, which often implies that there is a loop failure or something is going on with the loops that are causing variation of behaviors at the intersection, ultimately putting the intersection into some fail-safe operations. So really understanding what those insights are telling us, because ultimately getting to performance data, you can't really understand an optimization scenario without making sure the hardware itself is actually collecting what you need it to collect, and you're not there's no oversight in terms of you're missing a data point because the detector was broken or something is just not operating the way you anticipated it to. So you really have to address the maintenance and operation issues first before you can get into the performance. And this is really trying to highlight that for us in ways that we can unpack what may be going on and even provide helpful phrasing like detectors are deteriorating, and build on some of these alerts as well. And so as we build closer into these, and so if we go to say the equipment insights, it breaks it down really well, and say even giving you suggestions like consider replacing detectors, upgrading communications, additional detection should be needed, standardized phasing, power backup may be needed depending on what the maintenance issue may be, and then narrowing in even further on stop bar approaches or TMC type detectors, and really giving you full visibility and even recommendations of what potentially you should do about it. And so that's from a equipment perspective. From a maintenance perspective, looking at signal phasing operations, signal operations, then the phase operations themselves. So phases not being served, detected, detection stopped working, and then going really granular into each one of the detectors and some of the behaviors that are occurring. And you can already probably guess, based on some of the items on this page here, that it's very much constructed around vendor agnostic. So it could be a loop, could be a radar, could be Myovision's video detection. You want to know anything about your infrastructure regardless of the sensor, and this is really highlighting some of those behaviors, including PED detectors. Making sure our PED detectors are working the way that they should be is ultimately a really important piece as well. Building on that a little bit, looking towards the traffic controller, understanding it is doing all the traffic controller functions that you expect it to be doing. Is it going into the right cycles? Is it coordinating properly? Is it going into faults? Really getting that visibility that you would like out of your network. So the whole purpose of the insights is to really understand, is my intersection and are my corridors in my network are operating the way that they should be, so that we can ultimately understand our data in a better way. So going over to the data side, I'll just use a signal site. So along the left here, we have a signal list. There's going to be some performance measures, there's some trend data, and then ultimately our dashboards. And so quickly looking at some of those performance measures, this is a high-level view of them, but you can really see between stop bar and advanced detection, we're collecting a lot of the standard tools like approach volumes, delay, arrivals on green, split failures. Queue lengths is a really exciting one that's in the platform. You can really understand the demand that you're trying to serve. And then you can ultimately break really granular into a lot of these. And you have the whole list of each one of these. So you could go right into, say, queue length and understand what is the typical queue lengths occurring at the intersection. And we have a really high level worth of data as you go further and further into the intersection itself. And so the whole idea is that you can start at a high level of problems, work your way into trends of intersections that you're seeing in terms of performance, and then start unpacking the individual metrics that may point to the exact problem. Going back to a trend option, so really looking at not just a single day, but even if we expand this out to, say, the last month, and we apply that data set, understanding, is that a consistent thing over time? You don't want to make a decision off a single day's worth of data. You want to look at trends. You want to understand, is that normal? Is that not normal? And start unpacking it from multiple different perspectives in a way that you can really understand where the problems are coming from. So Traffop is geared around providing you the tools to dissect problems from multiple levels and multiple time frames, so that you can zero in on what you should do about it. Then flipping these into those executive reports, so that we can really understand the impact of changes that are occurring between level of service, total delay, emissions, and ultimately the total economic impact of an intersection itself, and compare that before, after various changes to easily articulate the impacts of the work that the team is doing and accelerate the efforts overall. You got to be able to build on what you did before, and measuring before and after is a big part of that. So lastly, I'll just quickly end on going up one more layer from a signal to an actual corridor. So not necessarily just applying at a single intersection over a period of time, but then taking that same concept across an entire corridor, looking at where is delay occurring in a corridor. Is it about signal coordination? Is it about the total volumes coming from a very particular location in the network? And where is that overall coordination breaking down through arrivals on green versus arrivals on red, side streets, downstream, and so on. And so you can see the granularity of this platform in a way that you can really start at a high level question of, I'm trying to improve emissions, I'm trying to reduce delay, I have citizen complaints coming in, and then providing you with a tool set that can help you go in that same order of transitioning through data from all layers, so that you can certainly address the problems that are occurring and then articulating the improvements that you have made. So that's all I'll cover today on the platform. I know it's probably quite a bit to digest all at once. We would be happy to set up individualized webinars and demos to really show you the whole power of this platform. It's a really helpful tool, and a lot of agencies are starting to adopt it as their standard performance measure tool, and we'd be excited to talk to you about that more. So hopefully that was a good intro to the product and an exciting future for all of us. So maybe I'll go back to the presentation and see if there's any questions maybe I can answer, or see what Harrison wants to do next. Can't hear you, Harrison.
Sorry, I was on mute. Thank you again. That was a very informative presentation and great demonstration. Right now, I'm going to go through some questions and just take a look at the questions tab here. We have our first one from Sabab Akbar. And this question is, how is the severity of issues at each intersection determined? Based on which criteria? So I believe that's related to the issues that tab that you showed in the demonstration, possibly on the grades that you showed earlier. I had a similar question myself on how you were determining what your operational issues were.
Yeah, for sure. Sorry, I should have probably included that slide in the presentation. I should have anticipated that question. But yeah, so there's a series of different types of severity. Critical issues like power loss or flash alerts, those would be your highest level. Those would be like certainly the most impactful terms of equipment insights and maintenance insights. So I'll go back here for a second. Really understanding, is it safely operating? And if it's not safely operating, like signal flash states, those are your highest priority. Those are the critical alerts. Then you get into a sub-degrading modes where it's intermittent and you're starting to see it working sometimes but others. So it's more about consistency of the issue, not necessarily. It's both critical and consistency. So critical issues are safely operating pieces, and then non-critical issues would be, say, a detector is stuck. And then changing and evolving states of that also go into the severity as well. So it looks at all of those factors, with the critical ones being just safe operating like signal flash or power loss, and then less critical being the detector statuses themselves, and making sure that at least it's going into fail-safe recalls and operating, and then it can move its way up the list in terms of degrading mode based on that severity. I do have a full breakdown of each one of the alerts and each one of the severity buckets for each one of the maintenance, equipment, and operation that we can maybe send out following this.
That sounds great. That sounds great. Thank you, Brent. Next question from Mohammed Essa. Approximately, what are the initial and operational costs for installing one 360-degree camera at one intersection? Good
question. So there's what are the initial and operating costs for installing one camera? Maybe that's a question we can follow up with you directly on. There's a few different factors like installation costs from contractors versus scoping out different intersections. A typical intersection with a single camera would be different than a dual camera or even a complex underground. So maybe we'll follow up directly with you on that one to make sure you get an accurate quote on the pricing.
Yeah, I'll touch base with you after this presentation, Mohammed. We can look at your situation and I'll go over costing. The next question from Mohammed again. In addition to detection and counts, can we get trajectories for further analysis, i.e. traffic conflict analysis?
That is a great question. You probably, as we were going through it, you probably caught that the building blocks of conflict analysis are there, which is true. So at the moment, the answer is no. Our platform doesn't directly provide those yet. We do use those in the background to allow for the ability to do that in the future, and we are partnering with some companies that are capable of doing conflict analysis today, and they're leveraging our video and our data to do their conflict analysis as well. We are including things in our data set like red light running and like pedestrian compliance, where it's components of conflict analysis. So where are the pedestrian spatially, where are the vehicle spatially, and where are they complying with the intersection statuses. which isn't quite conflict analysis, but there's further building blocks that we're working towards to get towards conflict analysis. So at the time, for now, the answer is we're just doing those individual components, but that leaves the future open for us to be able to do that in the future, or partner with companies that can do it today. So if that is a thing that you're trying to solve, maybe Harrison, when you follow up on this question as well, see if we can help further with it.
That sounds great. Yes, I would be happy to. Our next question from Jinsong. How does it send out data? I'm not sure if this is related to Traffop or Myovision, but maybe to be on the safe side, Brent, we can answer this regarding Traffop and then regarding Myovision, TrafficLink.
Sure. So from Traffop, he just clarified.
Good.
So the way Traffop works is, if I'll go back to that slide, the way this works is, so because it's vendor agnostic, it's not based on a cell connection or anything in the traffic cabinet itself. So one of the prerequisites is that there is communications established between the signal and the city network in general. And then anytime that they're connected, what we essentially do is we load a software client onto a virtual machine on the city network that essentially goes out and collects the high-res data over the network from the traffic controller, those FTP folders of high-res data, collects them up onto the virtual machine, and then in an outbound connection to the Traffop platform, provide the data into the performance measures to the correct intersection, and we can build the data set. So it's an on-premise service that collects from the traffic controllers the high-res data, and then it's provided to the platform. So we can leverage your existing communications, and it just simply runs on a virtual machine. Hopefully that answers the question. Oh, there you go.
Makes sense. That makes sense. Excellent. The next question from Haley. Are there any concerns of possible hacking of the Wi-Fi sniffing device for the MAC address capture? How secure is this? I believe this is related to TrafficLink.
Yeah, great question. Security is an incredible part of the Myovision team and the development group here. We have our own security staff and counsel on our teams, and they take these things very seriously. The Wi-Fi MAC address is a undiscoverable Wi-Fi signal in a way that we're allowing devices to identify to the Wi-Fi sniffing without actually capturing what their MAC address is or their ability to take even our MAC address. But it's secured in the way that we're only capturing that there was a thing, not necessarily a connectable like it's not a connection that anybody can connect to. So it's not like your Wi-Fi router that you would with an internet connection. You can't connect to it from a device. It is simply just collecting that there was a moving object in a way that we can anonymize and identify it in a way that we can find it in a different location as well and provide the travel time data, but it's not a discoverable connection that any device can actually leverage. And furthermore, not being able to discover it, actually encrypting it in a way that we can monitor the traffic and we can monitor the communications on the other side of the data just to make sure that it remains secure. And we use VPNs and virtual private servers and VPNs to make sure the entire connection end-to-end from device all the way up to our cloud product is completely encrypted and safe from the outside world. So it is not a connection that anybody can see or leverage.
Excellent. Sounds good. I have one question, Brent. I hope you don't mind. I'm going to try and make it quick. But I noticed on the Traffop dashboard, there was an average cost associated with each intersection or corridor. What factors go into what variables would be included in computing that average cost for your intersection? Is it based on your local gas prices, or like what factors do you use to get that value?
So one of the great parts about every feature and function in Traffop is there's a little question mark in the top right of every chart that actually shows you how it was derived, how it's built, and gives you some basic understanding of how it works. And so what we're using currently right now is it's not necessarily localized, but it's using a common factor of labor cost. So there's there's two different components, I guess. The labor cost of individuals, or the minimum wage costs, as well as the gas prices. And everybody knows that there's quite a variable gas price going on. And Canada actually has a much higher minimum wage than many places in the US as well. So we've standardized a little bit how we do labor and emission costs to help with some of those fluctuations in costs. And then we estimate the cost based on a common average across the network, which really helps us give a conservative estimate of what the total cost is. It's often higher than the number that we're providing because people do get paid more and gas prices are going up. So we're taking a conservative approach to some degree, and we're including a $15 an hour labor cost, and we're taking the total emissions that would be assumed multiplied by, I guess we don't put the rate. Do we put the rate here, or is it just my screen? Which is more of the current gas price that we are seeing, which it comes from an API that we do have that tries to put it on aggregate across all of North America. So it is one price. We're not taking a local price, but we are taking these two factors into consideration, and we do have some plans to consider localizing it in the future.
Very cool. Yeah, I could see this tool becoming even more beneficial as, the gas prices only seem to keep going up and the cost of labor only seems to keep going up. So, I could see these values really starting to shine some light on what the cost is of your intersections if they aren't optimized to the full stability. But thank you very much. It looks like we have one more question here from Jinsong. Are the features different from current ATMS platforms, being from Myovision or others? Features different from current ATMS? From Myovision.
Yeah.
Our feature, right, yeah.
Yeah, I'll try, hopefully I answer what you're trying to ask here. Many of the ATMS systems leverage, this is probably the wrong word for it, but a smaller or lower resolution of data. So the NTCIP streams from the traffic controllers, which provide about 30 or so events from the traffic controller itself, or even just the SDLC stream from the detection products, that really just gives you a small subset of signal status, pedestrian signal status, and detector status. What Traffop is doing is actually leveraging the high-res data, which is about 185 different events being captured from the traffic controller in a way that you can not just dissect what is the current state, but it's using that high-res data to understand the exact programming of the controller, as well as the current operation from any one of the types of devices that may be providing that sensor. And so we're not taking that lower resolution, I know that's probably not the right word for it, the lower event source to make decisions from. We're taking the highest resolution, which is the performance measure, which is the optimal way to look at performance measures and make the right decisions from, regardless of the sensor source. So you can really think of this as a true performance measurement tool to really help you understand how to optimize your timing plans in your intersections, whereas an ATMS doesn't necessarily go to that level, and it more so focuses on managing the timing plan itself and not necessarily the optimization. And so Traffop really focuses on that high level data or that high resolution data to get to the real heart of the problem.
Mm-hmm. Yeah. So it makes sense to run Traffop as a higher level solution within another ATMS structure, because this is going to provide more features than a basic platform that should be common in the market today.
Exactly, yeah.
Excellent, excellent. Well, looks like the questions have stopped coming in. So maybe we'll just quickly introduce our next webinar that's coming up. The next webinar will be held on July 6th between 1 to 1:45 p.m., hosted by Sherry Walwell from Stinson ITS. She's our Western account manager, and it's going to be focused on LYT, or known as LIGHT. LYT is a cloud-based software platform that uses state-of-the-art connected vehicle and machine learning technology to provide transit signal priority and emergency vehicle preemption, and it helps prioritize the flow of vehicles within the city. So essentially what we're doing with LIGHT is creating a TSP and EVP network and taking the hardware from the controllers out of the equation and running your TSP and EVP solution through a cloud-based system. So I'm really excited about this product, and I'm really excited to have you on our next webinar. And if you have any information that you'd like to gather regarding network-based preemption in TSP, please feel free to reach out to myself or any of the other account managers at Stinson ITS. Would be happy to share any information on LYT or this current webinar regarding Myovision's traffic. the core platform, and Traffop. Again, thank you very much, Brent. That was a great presentation, excellent demonstration. And we had some great questions as well. And I'll be looking to follow up with anybody else who had questions that maybe perhaps they'd like more information. So again, feel free to reach out to myself, and I'll be happy to provide any additional information on Traffop or Myovision's core solution. Thank you
Awesome.
again.
Thank you, everyone.
Thanks, everybody.
Thanks, guys. Appreciate the support.
Thank you so much.